Right, so welcome to today's special online class in order to make up for the medical leave post-concussion. What we're going to be doing today is we're going to be introducing Chapter 9, the t-test for independent means. This is our final t-test, the last version of a t-test that we're going to be taking a look at. So we're going to introduce that idea in order to deal with experiments where you have two separate groups of subjects, each that are measured one time. So for example, there's a very famous study by Loftus and Palmer that was looking at how the wording of a question can actually affect and change your memory for an incident. So if you were a psychologist that was brought in to investigate or brought in to advise on eyewitness testimony about a car crash, it depends upon how the individual was asked about that car crash. Their memory will actually change and depend upon how they were asked. So this individual right here, if he was asked how fast were the cars going when they hit each other, psychology has shown that he will give a lower estimate than if he's asked how fast were the cars going when they smashed into each other. So we're going to take a look at the t-test that Loftus and Palmer would have used to analyze the data on that groundbreaking experiment that shows that our memory is very fluid and changes depending upon how we are asked the question. But before we get to that, we got one last little thing to finish off with SPSS and the dependent means and one sample t-test, and that is how to deal with one-tailed versus two-tailed hypothesis tests. So this is in general for a t-test, how to deal with one-tailed or two-tailed hypothesis tests using SPSS. We know how to do it with the critical t-scores and the sample t-scores. Now we're going to take a look at how to do it with the alpha levels and the probabilities. And then we're going to introduce the idea of the hypothesis test using a t-test with independent means, and then show you how to do that with SPSS. And then I'll mention some extra practice where you can practice these skills to continue to develop your SPSS ability. All right. So you recall that in the hypothesis test with the t-statistic, step number 5, when you're deciding whether to reject or accept a null hypothesis, we've changed that to dealing with probabilities. So if the p-value is less than your alpha level for the experiment, you accept the research hypothesis, you reject the null hypothesis. But on the other hand, if your p-value is greater than your alpha level, you accept the null hypothesis and you reject the research hypothesis. So when we were looking at our t-test, we showed you where to find that p-value. And in this case, for this dependent means t-test that we saw last time, that significance value, that is your p-value. So when we were doing this, we were doing a two-tailed hypothesis test. And if you take a look at the table here from SPSS, it literally tells you that this is the two-tailed probability. So for a two-tailed test, we can read that number directly off of SPSS because it gives us a two-tailed probability. So when we're doing that final decision, decide whether to reject the null hypothesis, we take the p-value directly from SPSS, so p-value equals 0.008. Our alpha level we get from our question, alpha level equals 0.05. Our p-value is less than our alpha level, so we reject the null hypothesis, and that's what we did last time when we were doing a two-tailed test. However, sometimes you're going to want to do a one-tailed test. So sometimes the question will ask you to do a one-tailed test. And the key thing here to realize is that SPSS will always report the two-tailed test. So there is nowhere in SPSS where you can go in and change SPSS's output so that significance is a one-tailed significance rather than a two-tailed. So when we're doing a one-tailed test, it's on us. We have one more step that we need to do in order to get the correct probability, the correct p-value. So SPSS will calculate the two-tailed significance, the two-tailed probability. Remember that that is the proportion in the distribution for two tails. So if that's the probability for two tails, then if we want to do a one-tailed test and SPSS has given us a probability for two tails, what we need to do is we need to take that probability and divide it by half to get rid of one of the tails. So the only step that we need to do is we need to take that p-value and we need to divide it by 2 in order to get the one-tailed probability value, in order to get that one-tailed t-test p-value. So this 0.08 divided by 2 is 0.04. We compare 0.004 to our alpha level of 0.05, and once again, in this case, we would reject the null hypothesis. So the key here is just to realize that in that SPSS output, it will always give you the two-tailed significance, that two-tailed p-value. If you need a two-tailed p-value, if you're doing a two-tailed test, then you're ready to go, full speed ahead. You can just take that value, compare it to your alpha, and make your final decision. If, on the other hand, though, you're doing a one-tail test, you just have to take a moment, realize that SPSS is giving you the probability for two tails, and then you take that value and you divide it by half to get rid of one of the tails, the tail that you're not interested in, and that p-value divided by 2 is what you compare to your alpha level for that one-tail test. All right, so now you have everything that you need to do or you need to know in order to do homework assignment number 11 for both two-tailed and one-tailed tests using SPSS fully. So using the old t critical values compared to the t sample statistic, that one-tailed, two-tailed test is the same as before. We've been doing that previously. This is the new thing, though. If you want to do it completely in SPSS, you can still do a one-tailed and two-tailed test in SPSS. You just have to, in a one-tailed test, take that p-value and divide it by 2. In a two-tailed test, you can just take that p-value, and SPSS does very nicely label it as a two-tailed p-value. All right, so now on to the new stuff. What we're going to do is we're going to do a demo problem covering the t-test now with independent means. So we've done a one-sample t-test. That was Harlow's Monkey's t-test. We've done a dependent means t-test. That was the 5-second, 10-second timeout t-test. Now we're doing the final major version of t-tests, and this is the t-test with independent means. So read the description here. So in 1974, and if you want to read the original research, that is available to you in Canvas. But in 1974, Loftus and Palmer conducted a classic study demonstrating how the language used to ask a question can influence eyewitness memory. In the study, college students watched a film of an automobile accident and then were asked questions about what they saw. One group was asked about how fast were the cars going when they smashed into each other. Another group was asked the same question, except the verb was changed into hit instead of smashed into. The smashed into group reported significantly higher estimates of speed than the hit group. Suppose a researcher repeats the study with a sample of today's college students and obtains the following results. So we have our estimated speed. For the smashed into group, we have 15 subjects. Their mean estimated speed was 40.8 miles per hour. For the hit group, we have 10 subjects. Their mean estimated speed was 34 miles per hour. And notice that these two groups, these two samples, are of different people. 15 subjects were asked how fast were the cars going when they smashed into each other, and nothing else. The other 10 subjects, 10 different subjects, were asked how fast were the cars going when they hit each other, and nothing else. So we have 25 subjects in total, 15 in one group, 10 in another group. The two groups are independent of each other because they're made up of different people, hence the independent means t-test. Do the results indicate a significantly higher mean for the smashed into group? Use the two-tailed test with an alpha of 0.05. So if you recall before, when we had our t-test with dependent means, we would take a sample and we would measure it before treatment, and then we would take that sample and treat it, and then we would measure it after treatment. That was a dependent means. We had one sample. We measured it twice. For an independent means t-test, we now take two samples from the unknown population, and we treat one of them. So the comparison then becomes between the sample that we treated and the original sample that was untreated. So again, this is two samples, one which is treated, one which is untreated, two samples which are treated differently, two samples of different people operating independently of each other, hence the independent means t-test. So in this case, one of these samples, excuse me, the sample from the treated population was asked how fast were the cars going when they smashed into each other. Sample number 1 from the unknown population was asked how fast were the cars going when they hit each other. And the question is, by asking these subjects how fast were the cars going when they smashed into each other, did we transform them into a different population with higher estimates of speed? All right, so these are the data that we have right here. So for the smashed into group, we have 15 subjects, and those are their estimates of how fast the cars were going when they smashed into each other. For the hit group, we have 10 subjects, and those are their estimates for how fast the cars were going when they hit each other. And what we want to know is, do the two samples indicate a difference in the population of witnesses who are asked how fast are cars going when they hit each other versus the population of witnesses that are asked how fast the cars were going when they smashed into each other? In other words, does the way that you phrase a question change your memory for an incident? All right, so this is the t-test with independent means. However, it is still a hypothesis test. So we're still doing the 5 steps, the 5-step procedure, and we're still starting off with restating the question as a research hypothesis and a null hypothesis about the population. So we're still asking ourselves, is there a difference in the speed estimations between the smashed into and the hit groups? So is there a difference in the speed estimations between these two groups? The research hypothesis, and this is a two-tailed hypothesis as the question stated, the research hypothesis is that there is a difference in the speed estimates. So this is written as the mean speed for the smashed into population does not equal the mean speed for the hit population. And if this is true, that means that that smashed into population excuse me, is a new population. It's a treated population. It is different than the hit population. So that's what the research hypothesis is asking. There is a difference. The mean of the smashed into population does not equal the mean of the hit population. The null hypothesis has to be the complete opposite of the research hypothesis. So if the research hypothesis is that there is a difference in speed estimates, the null hypothesis is that there is no difference in speed estimates. If the research hypothesis is that the smashed into mean does not equal the hit mean, the null hypothesis is that the smashed into mean does equal the hit mean, and that would indicate that the smashed into population and the hit population are the exact same populations, and asking that question does not change people's memory for the event. All right, so that's the research in the null hypothesis. Now we have to determine the characteristics of the comparison distribution, and SPSS will do this for us, and there is a lot of heavy lifting for the t-test with independent means, so this is where we're really thankful that we've given the heavy lifting over to SPSS. We got to set a cutoff sample score or critical value. For your homework, you're still going to have to look this up off of the T statistic table. However, we are now moving away from setting cutoff sample scores to setting a cutoff probability. And the cutoff probability that we are using is that alpha level that is given to you in the question. So don't get confused. It's rather straightforward. Your cutoff probability is your alpha level, and your alpha level in this case is 0.05. Now, we mentioned before when we were looking at one-tailed and two-tailed tests that sometimes for a one-tailed test, when you take your p-value, you divide it by 2. And just so there's no confusion, you never, ever, ever touch your alpha. All right, alpha it's there in the name. It's alpha. It's the first. It's like VIP status. You never touch your alpha. Whatever your alpha is given to you, it's a probability, much like your p-value, but alpha is alpha. You do not touch it. So I don't ever want to see anybody dividing alpha by 2 or doing anything else alpha. Alpha is alpha, and in this case, for this question, alpha is 0.05. All right, step number 4, determine your sample score on the comparison distribution. This has changed now to determine your sample's probability on the comparison distribution, and that is the p-value, and we will find this when we take a look at where it is in SPSS. So once again, we're going to now do a live run-through with SPSS to run this independent means t-test. If you're following along, the data can be found in Canvas in file 23 practice, November 9th, chapter 9, the t-test for independent means Excel file. As always, we have screenshots and also in your PowerPoint notes, and also we have this video here today. So I'm going to go at a certain speed through this video that I find comfortable. For you yourself, if it's a little bit too fast, pause the video whenever you need to in order to catch up. But as well, you can follow along with the PowerPoint slides that we've been that are included. All right. So without further ado, here we have our eyewitness memory data. So let me zoom in on that. All right. So here we have our smashed into data. So we got 15 subjects. And these are their estimates of speed. So subject number 5 said that the cars were going at approximately 40.8 miles an hour. Subject number 12 said 48.49 miles per hour. And then for the hit group, here we have the 10 subjects, 10 different subjects in the hit group. And these are their estimates of speed. So as we've seen before, we need to get these speed estimates, these raw scores, into SPSS. So how are we going to do that? Well, we'll start off the way that we normally do, and we're going to highlight one set of scores, and we're going to copy and paste that, and we're going to put it into SPSS. So highlight the smashed into speed estimates. We're going to copy that, and then we're going to go to SPSS. And remember that the shortcuts for SPSS, many of them are the same as the shortcuts for Excel. So however you like to paste in Excel, feel free. I like to use Control-V. So we paste that, excuse me, we paste that into SPSS. And true to form, SPSS, the robot that it is, has named this variable var00001. Great name for a robot, horrible name for human brains. So we're going to go down to variable view, and we're going to change this into a name that we can understand. Namely, we're going to change it into speed. So we're changing var00001. And I seem to have lost my... Oh, there we go. So we're going to change var00001 into a new variable called speed. And that's just to jog our memories. That's what we had. We used speed. That is what those raw scores actually are. So the next thing that we're going to do is we're going to go to the second column over here, and we are going to label each of these scores as belonging to a certain group. And the scores that we're going to label them as belonging to is the smashed. And there appears to be a bit of lag. So much for going at a comfortable rate. We're going to label these as belonging to the smashed group. Okay, so I am going to just go here and write smashed, and hopefully when I copy and paste that, it'll work in... There we go. So we're going to label each of those as being part of the smashed group. And in order so that we don't get confused, we're going to go back to the variable view over here, and we are going to change the name of that variable to smashed as well. No, actually, sorry, we're not going to change it to smashed. We're going to change it to group. Okay, so notice that, and this is something that SPSS, we really haven't had to worry about yet so far, but notice here that SPSS, in that second column in your variable view, labels your variables as what it thinks is in those columns. So for the speed variable, we gave SPSS a whole set of numbers. And SPSS says, hey, I think you're giving me a numeric variable. I think you're giving me a whole bunch of numbers. And that's exactly what we wanted to do. So that's going to work. For group, however, we gave it a whole bunch of words. We said, hey, this is the smashed group. And SPSS came back and said, hey, you're giving me a string. String is the computer word for words. It basically said, hey, you're giving me a whole bunch of words. When those types of variables, when SPSS guesses that correctly, we typically have a very straightforward hypothesis test to conduct. Sometimes, however, SPSS will guess incorrectly, usually because we messed up and put in a word where the number should have been, put in a number where the word should have been. We did something, and SPSS will mess up and think that we're giving it a whole bunch of words when we're actually trying to give it numbers. If anything goes weird and wonky with your t-test, that's a good place to check, especially if you're missing variables. So if you're ever missing variables on your t-test, check to make sure that your variables are of the right type. And if they're not, you can simply highlight that column, hit delete, and just start over with formatting that column. All right, so we have the speed for the smashed into group. So now we need to transfer the speeds for the hit group. And as always, the question becomes, where do we put this data? So do we put this data here in a third column? And then in the fourth column, we're going to label this as the hit group? Or do we put it down here in row 16? And then in the second column, we're going to continue with the labeling of the different groups in this t-test. Well, again, the answer comes from one of the guiding principles of organizing data in SPSS, and that is that every single row is reserved for one subject and one subject only. So subject 5 gets row 5, and that entire row belongs to subject 5. Subject 12 gets row 12, and that entire row belongs to row 12. So here we have 10 new subjects, and we cannot put them in any other subject's row. We need to put them in 10 new rows. So the only way we can do that is to go to row 16 in that speed column, paste our scores there. That's where they need to go. And now we just need to tell SPSS that the other group in this experiment is called the hit group. So once again, we just label each of those rows as being part of the hit group. And now we're ready to go. Now we're formatted correctly, and we're ready to tell SPSS which t-test we want it to run. All right. So we're going to go now to analyze. And once again, we're going back to compared means. And this time, we want to do an independent means t-test. And SPSS is being very friendly because we do have something called the independent samples t-test. And that is the test that we're looking for. So we want to do an independent means. SPSS says, I got this thing called independent samples. And we as humans say, that is exactly what we want. So we click on that. So once again, analyze, compare means. Click on that independent samples t-test. And now we get this independent samples t-test dialog box. And we need to determine which variable goes into the test variables window and which variables goes into the grouping variables window. So the test variable window, that is where your raw scores go. So the raw scores, the scores that you recorded, in this case, the miles per hour estimates, go into the test variables. The grouping variable is a little bit easier to remember. That's where the names of your groups go. So in this case, we're going to take the speed variable with our miles per hour estimates, and we're going to put that into the test variables box. And of course, if you ever make a mistake, you can always just pop it back out using those little arrow buttons. And we're going to highlight the group variable, and we're going to stick it down here using this arrow into the grouping variable box. Now the last thing we got to do is you can see that SPSS is saying, oh, you have 2 groups, but I got a question mark here. What do you call them? What have you named your 2 groups? So to finish off setting up our independent samples t-test, we have to go here to define groups, and we have to tell SPSS who is group 1, and group 1 is smashed, and we have to tell SPSS who is group 2, and group 2 is hit. And then we hit continue, and we're ready to run our independent sample t-test. This is another place when things can go wrong, because if you misname your groups, SPSS will not figure it out for you. So for example, if instead of smashed, I said, oh, one of my groups is called smash, and the other one is called hit, then when I ran my independent samples t-test, it would give me this output up here, and it will literally say an independent samples table is not produced. It will literally say you got nobody in that smash group. So if anything like this happens, if you end up not being able to actually run a t-test, so you told SPSS to run your t-test and it comes back with garbage output like this, double check your how you set up your group names. Go back to the independent samples t-test, go back to define groups, and just double check and find out that, oh, we put in smash instead of smashed. Of course, nobody's in the smash group. Everybody's in the smashed group. So now we have that correct. All right, so just a couple of warnings about where things can go wrong and what to do if they do. But now we've got everything set up correctly. So we're going to hit OK. And lo and behold, we get our output. And SPSS has run our independent samples t-test, crunched all the numbers. So now it's up to us as humans to figure out what do these numbers mean, to do the interpretation, to finalize this independent means t-test. All right. So now it's time to decide whether or not to reject the null hypothesis. Remember the old rules. If the sample t-score is beyond the cutoff t-score, we accept the research hypothesis. We reject the null hypothesis. If the sample t-score is within the cutoff t-score, we accept the null hypothesis and we reject the research hypothesis. This is still true. This is the way that your homework is going to want you to do it with sample t-scores and cutoff t-scores. So don't forget about this. Don't, throw this to the wayside. This is still one of the ways to do it. However, this requires you to look up the unit normal the t-test distribution tables to figure out those cutoff scores. So to kind of cut out that middleman and to make it more ecologically valid, this is the way that people typically do these t-tests using SPSS in the real world. We're going to go from cutoff scores and sample scores to p-values and alpha levels. So your alpha level is your cutoff score, your p-value is your sample statistic, and if your p-value is less than your alpha value, you accept the research hypothesis and you reject the null hypothesis. You're basically saying that your p-value, the probability of this sample happening randomly, is so low that there must have been a treatment effect. There must be support for that research hypothesis. However, if your p-value is greater than your alpha level, that means that a difference that we found could be due just to fluke, very likely. So in that case, we accept the null hypothesis if the p-value is greater than alpha, and we reject the research hypothesis. So we go back, and now it's time to take a look at our data. Now it's time to take a look at our tables to see what we want to do. So as always, you don't want to just go barreling towards that p-value. You want to find out where you can find all the information that we need. And very importantly, especially for exams that are coming up, just to keep it real, make sure that you check that top table for evidence that you've entered in your data correctly. So very nicely in that group statistics table, in that top table there, SPSS has labeled one group as the smashed group, it's labeled the other group as the hit group, and right there it's told us, hey, I got 15 scores in the smashed group, and I got 10 scores in the hit group. And it's up to us to double check those numbers and say, yeah, that's how many scores you should have. So I didn't slip, I didn't have a finger slip when I was labeling these groups. That's exactly how many scores you should have. It's also calculated the mean for each of those groups. So compare those to your values in Excel. Make sure that you didn't miss a score or duplicate a score or change something about one of the scores. That's what the scores should be. That's what the mean should be. So that gives us confidence that we've done this correctly. Next thing we do is we actually look for the comparison distribution. For that, we need to go down to the bottom table, that independent samples t-test table. And you'll see that there's 2 rows on this independent samples t-test. We're going to stick to the one that says equal variance is assumed. So the equal variance is assumed. That was an assumption that made the mathematics of statistics way easier, especially in the pencil and paper days. And as it turns out, it's often an assumption that is true. So when you take statistics in grad school, you'll learn all about the equal variance is not assumed. But because this is your intro into statistics, we are going to stick to that top row, that equal variance is assumed row. That's the row that you're going to be using. So those are the numbers that we're going to be using. Ignore that second row. Stick to that equal variance is assumed row up at the top. All right, so what are we looking for here? We're looking for our comparison distribution. First thing we need is the mean for the comparison distribution. So the mean for the comparison distribution, much like for a dependent means t-test, the mean for the independent samples t-test comparison distribution is always going to be 0. And that's why it's not output in your Excel output. It's always 0, so we don't have to output it. We don't have to calculate it. As soon as we're doing an independent means t-test, we know the mean of our comparison distribution is 0. What about the degrees of freedom? The degrees of freedom, right there, SPSS reports it. We have 23 degrees of freedom. This is one of the first times where the degrees of freedom gets a little bit complicated. It's the size of the first sample minus 1 plus the size of the second sample minus 1, or just know where to look for it in SPSS. We got degrees of freedom equals 23 right there. The last thing we need is the estimated standard error, the standard deviation of the comparison distribution. And in this case, we got 3 sets of numbers across 2 different locations that have the word standard error in their labels. So if you look at that first table at the top, you see the standard error of the mean, and we got 2 numbers there. If you look at the table at the bottom, we got standard error of the difference, and we have 1 number in that top row. Which one of those do we want? Well, we want that one in the second table. So make a note when you're looking for your comparison distribution. When you want that estimated standard error for your comparison distribution, that's the number you're looking for. It's labeled standard error of the difference in that second table. All right, so that's a comparison distribution. Step 3, we want our cutoff probability. Remember, that's your alpha level, so we're done with that. Use that alpha level for your homework to find your cutoff t-statistics using the t-statistic table. But we can go on to step 4, where we're looking for our sample probability. So SPSS calculates the mean difference between the two samples, and then that mean difference is divided by the standard error of the difference, and that gives you this t-statistic right here. So in your homework, when it's asking for your sample t-statistic, that's where you find it in SPSS. That's where it lists. It's done the calculations for you. It's giving you that t-statistic. That's the t-statistic that you would compare to your cutoff scores. But in this case, we're just going to use SPSS, so we're not going to go to the the t-distribution table. So that t-statistic, we would report it. However, in order to figure out what we're going to do for our hypothesis test, how we're going to conclude it, we need to find that p-value. And in this case, it also is a little bit devious, a little bit tricky, because in our independent samples t-test table, there are 2 columns that are labeled with significance. Significance is probability, and there's 2 tables that are labeled sig. make a note. The one that you want is this one that says two-tailed. So don't get confused and go for that other one. Don't get confused and go for Levine's test of equality of variances. That's not the significance you're looking for. The one you want is you want this one, the significance two-tailed, this 0.015. And because we are doing a two-tailed hypothesis test, we can take this number directly from this table. We don't have to do anything. If we were doing a one-tailed test, we would take this 0.015, we'd slice it in half, we divide it by 2. However, we're doing a two-tailed test, so we can read this directly off. Our p-value is 0.015. So now when we're deciding whether to reject or accept a null hypothesis, if our p-value is less than our alpha value, we accept the research hypothesis, we reject the null hypothesis. That is the case. 0.015 is less than 0.05. So that's our conclusion. We're going to accept the research hypothesis, reject the null hypothesis. If the opposite was true, the p-value was greater than alpha, we would accept the null hypothesis, reject the research hypothesis. However, as mentioned, our p-value is 0.015. That is less than our alpha value. So we reject the null hypothesis. We accept the research hypothesis. And our conclusion is that the smashed into group did actually have higher estimates of speed than the hit group. So the way that you phrase a question can actually change your memory or a person's memory for what actually happened. So if somebody was to ask me, how fast was my head going when it smashed into the curb side that when I wiped out on my bike, I would remember a higher velocity than if they asked how fast was it going when it hit, considering if I had any memory for it whatsoever. Anyways, thanks for joining me on today's medical leave catch-up. Before we end this, just a couple of reminders. First off, continue doing your pretest points. I'm going to be updating that in the gradebook very shortly as I continue to catch up with work that I missed due to the leave. So don't worry if your grades haven't been updated yet. I have the records. I just need to transfer them into Canvas and into Excel. For this t-test, I highly recommend try the extra practice. The questions can be found in the Excel sheet that we found the hit and smashed into data from. The questions can be found in that 23 practice, November 9th, Chapter 9th, the t-test for independent means PowerPoint files. And it'll give you the question. It'll give you the answers for all 5 steps of the process. It'll give you the SPS output that you should get. So try those out. And we will have a review session before exam 3. So if any of it doesn't work or if you're confused by anything, make notes. Ask me during the review session. We'll make sure that you are ready to go. And right now you're ready for your homework. So homework assignment number 12, Chapter 9, is going to be due November 14th at 11:59 p.m. So you're ready to go for that. A little bit of extra time to get that done, considering we have a few t-test homeworks to do. But that is all that I wanted to cover for today. So thank you so much for joining me for this special online class. And I will see you all next class as we continue to try to catch up on this semester. So once again, thanks for coming by, and have a great night.